Hi, everyone. I'm so excited to be here today. Today, we will attack Kubernetes clusters, and we'll dive into a chain attack in Kubernetes. So let me introduce myself. My name is Shiri, aka the container guy. I know online is the Black Dog. I'm working in Accenture Security Israel. I'm a Gland team. We're a consulting enterprise. I'm also, I have posted a lot of research about Kubernetes, low-level security. I love IoT devices. My hobbies are jiu-jitsu. I'm doing a lot of powerlifting and Nintendo Switch, a lot of cool things. So this is a bit about the agenda for today. We're going to learn about Kubernetes chain attack, these general issues about Kubernetes that works almost in every AWS environment. We'll talk about design issues. We'll learn about methodology for attacking Kubernetes clusters. We'll dive into two issues that exist by default, and we'll learn how we can utilize it in scenarios for taking over Kubernetes clusters. And then your favorite topic, we'll talk about mitigations by the end. So a bit about microservices to get started. So container is a virtual machine alike. Docker is the engine that runs the containers, and Kubernetes is the orchestration. So a little bit more into this. Containers are eventually processes that can running the application. Docker, as it's orchestrated and managing the storage and everything that's related to the containers. And Kubernetes runs the Docker containers, the Docker engine inside several nodes. A little bit about the architectural shift before we dive in more to the Kubernetes. So there's a change right now in the industry. More and more applications are moving to microservices. And why it's relevant? Because it has a new risk and new challenges. For example, if in the past every application ran in its own node, today it's running its own process in a Docker container. And it can be used in many things today. If we have, for example, a generative AI session or any kind of user session or an online game, it's usually run in its own container. So if there's a breakout or an exfiltrated container or something like this, any attacker can utilize those attacks to get and to see information about other containers if it got a breakout. So this is why it's becoming more and more critical. So as you know, the future is all containers, and that's because the CI/CD and DevOps and all of those things that you hear all day on Kubernetes are becoming more and more popular, and this is also because of Docker containers, and so also because of Docker container are so efficient. So as you can see here, we have the node. The node is eventually a VM. The node is eventually a virtual machine. It has it's a kubelet that's managing the pods. It has also the Docker engine inside the node. And the pod is eventually a logical unit that contains containers. In most environments, contain just one container. So we'll talk generally about pods. So this is how namespaces look like. Namespace basically aggregates together several pods. It should be isolated. So as you can see, it's very popular and very common to give in small organizations its own namespace for the production and namespace for non-production. And there are many other organizations that are giving front-end, a whole namespace for front-end, a whole namespace for a back-end. So as you can see, there's the control plane. Control plane is aggregates inside of it several services. If it's the main API, it's very common to target the main API, but by attacks. If it's DDoS service attacks or privilege escalation, because it's the central point, it also communicates with its CD database. And not everyone can talk, or not every API and service account can talk with this. It depends on the role-based access control that exists on the cluster. It's very common in Kubernetes to implement specific service accounts inside every pod. But today, it's very common to not implement them, of course, privileged ones, inside the main pod, the front-end pod. So to get started, we'll talk about the research in EKS, as we said. It's based on two flows that exist by design. And how we can utilize this for scenarios for takeover the cluster. And so this is our architecture for today's demo. We have two main namespaces, two main. We have, first of all, the front-end namespace that contains the attacker in one pod, the front-end pod. It doesn't have, the container is not escapable by default. It's with the default settings. And we have another namespace for the backend. And this architecture is very common and popular. We have also the ECRs that contain all the images of the containers. And we have the instance metadata that we're going to talk about a lot. So these are the most common ways and types of container breakouts that exist today. We have Docker CVE, if it's 0-day in the Docker engine or the runC or any component that's relevant to the containerization platform. We have also the Linux kernel. What? Thank you. So we have also Linux kernel vulnerabilities. Because of the shared kernel of Kubernetes, any privilege escalation in the kernel can lead to a container breakout. But these two are not very common. It's very known today, of course, with the CI/CD and the automation to update our containers, and containers are deployable in seconds. It's not a problem to upgrade your containers. We also had, and still have, ports and APIs, if it's a read-only port and many things like that. But all of those things are today in Kubernetes don't exist by default. It's probably by developers' mistakes and something that it's not very common. And it took 10 years to reach that day. Kubernetes today has 10 years to reach that day. But today, all of those attacks almost secure by default. So this is one of the most common attack methodologies that exist today for Kubernetes, for practical attacks. First, we try to get some kind of API access. If it's to get some service account or to break out to the node, because as we said, the node is very a good target, because if you get access to the node, you can access to every container. And other containers that are not the front end usually contain some kind of service account. And it has its own service account of the kubelet. After we got a service account, we try some techniques that we'll talk about today, how we can use those privileges to get more privileges, of course, or to get into some secrets or something that we can get into other platforms or customer data or something that is more interesting. So this is the attack chain that we're going to talk about. We're going to break it to phase by phase. First of all, it will start with access to the node role. Due to the implementation of the open source Kubernetes in the cloud, every cloud vendor has its own way to authenticate and manage the nodes, the EC2 instances, for example. So in AWS, we'll talk about getting access to the node role. Then we'll have two scenarios. First of all, in a case that this role is privileged or has some kind of custom roles that you can utilize some techniques to get pivoting to the cloud. We're not going to focus on this today. We're going to focus on something that is more common, and that's the default IAM permissions. In this case, we have several techniques that we can utilize. First, we'll see how we can, by default, to get access to every container image on the AWS. How we can generate a new Kubernetes API, and depending on its permissions, we'll see how we can see some techniques to take over the cluster and accessing all the secrets of all the containers. So the metadata. The metadata is in EC2, in every cloud, is providing information for cloud resources. It's called the IMDS, Instance Metadata Service. It's became one of the most popular attack vectors in the recent year, and that's because many attackers are utilizing this from SSRF attacks. SSRF attacks are very, when there's an SSRF attack, it's very hard to get into something that you can utilize it and to get access to infrastructure. But because that IMDS has its own roles that we're going to talk about, it became one of the most popular and aggressive attack vectors. And AWS came with the idea to create IMDS v2, that it has a put request to get a token. And using this token, you can get more privileges. You can authenticate to the metadata. And this needed to mitigate the SSRF attacks. But there's a Gopher protocol that you can utilize it to send put requests over HTTP. And this is why it's not, it's still a very good attack vector for web applications. And the EC2 by default has two main roles. It has the EC2 role that you cannot do a lot with it by default. And you have the IAM roles, the assume role that you can do it for integrations. But from my research, I saw that the default role of the nodes, that eventually it's an EC2, it's not the same role. It has more privileges by default for authenticating and with the cluster resources. The kubelet needs some kind of authentication with the cluster resources. So, as we can see, we send a put request to get a token. Using the token, okay, so we got the token. Using the token, we can authenticate with the metadata very easily. Here, I ran a script for network info. You'll get it by the end of the talk. And as you see, it's get all the MAC addresses, and using every MAC address, it can get the default, the security group, and information about every node that exists in the Kubernetes. And all this scenario from one pod of the front end. By default, it creates the security group with the name of the cluster. And we're going to need this on the next phases. Here we can get also the regions that we'll need, and also we can get the credentials, the role, and that's the first issue, guys. This is the role of the node, and we can get it from the containers by default. And there are many implementations for this in Azure, and also in Google, in GCP. But here they chose to use the metadata and not from saving it inside the node. And this is why you can get it from the pod that, as I said, in Kubernetes, by default, there's no way to get by default without any kind of exploitation to get information about other pods or this kind of API. You need to have or read only API on the cluster to authenticate. You need to mount some kind of service account and to have some developer best practice for getting it. And here we got the role. As you can see here, when we try to see what kind of privileges it has, we can see that it belongs to EKS nodes, system nodes. And this is a special Kubernetes group that it's under the kubelet permissions. And it has the same permissions, and it has read permissions on a lot of components in the cluster. If it's ECR, if it's, if it's cluster storage, config maps, and many more, much more. But the AWS role has very limited permissions in most cases. What we can do with it? So first of all, even if we don't have a lot of permissions, we can get, by default, it has permissions to get all the tags of all the AWS environment. By default, for any component and resource that is related to the Kubernetes cluster, AWS created by default a tag with the name of the resource. So you can know from this what kind of resources exist on the cloud, what their names, and how to continue targeting, and depends on the vulnerabilities and default settings. We'll not get into this, but as you can see here, this is a second way to discover what is the name of the cluster. And here, this is as you can see, by default, we have access to get the container images, even of other clusters. For this, we need the ECR token. After we got the ECR token, we can list the repositories, even without the token. But from here, we need the registry ID and the repository's URI. And we just can use this command to get, using the token and the registry ID, to authenticate with Docker from our local machine to the ECR. And with this, we can pull any image that we want of the running containers. And today, as a practice, many developers build their containers by layer, and they save, and a lot of containers have a password inside their images, databases, and from this you can understand what, and first of all to search for passwords, and again you need also from Docker Desktop, you can search to see layer by layer and every command that was executed with Docker, inside the Docker build file, and even to rebuild the image. And that was the first vector that you can get information about, if it's about customers or about for a lot of inside the cluster. The second issue that I saw that it says after reviewing the privileges and what I can do with it, so that I can mount using, if I get the name of the cluster, I didn't have any permissions to list the clusters, but if I find the cluster, I could create a new Kubernetes API. And this is the API I told you that it has, in default, the system nodes privileges. As you can see, most of its permissions are just read. The problem here is that by default, it has low privileges. Again, and what we can do with it, as I said, by default, you cannot get read access on other components. Solution, we'll talk about Kubernetes bypass techniques. You can do it and utilize it on every container that you want, on every service account that you find. If it's limited, it's probably one of the techniques is going to work. First of all, I didn't have access to list namespaces, but I had actually the privilege to list services. Using services, you can see all the ports of every container that are open without active scanning. And from here, you can target them and try to connect them and to use those services. If it has, Kubernetes relies on integrations, and if it's like every other system, if it's to implement some monitoring, and many times it has central containers like Kafka and databases that needs connections. And here you can find what kind of connections exist on the cluster, and you can get also the namespace that you can use it to target on the next slides. We'll need specific as the name of it. And it has also privileges to list the name of the pods on different namespaces. As you know, we started from the front-end container, but we can see the backend pods names. Just a second, it stopped working. Okay. As well, if we want to see some kind of secrets of what used to build the container over the image, and to see what kind of data exists there, we can. We don't have access to deployment because it has the same privileges for managing that's needed for managing the containers from the nodes. And we don't have access to secrets, of course. How we can get it? So we can see, we don't have deployments, but we can see the manifest. And the manifest contains the runtime settings of the container. It contains many environment variables. It contains all the integrations of it. As you can see, any environment variable, this is from the lab. We can see any integration that exists. We can use it with the secrets. And we don't have permission to list secrets, but we can get the name of the secret using the manifest, as you can see. And using the name of the secret, we can list the value using the option -o YAML. And here we can see the secrets with the strongest encryption of a base 64. So exploit what we can do. So by default, we don't have access, of course, for creating deployments. And we don't have access to create services. But I found it very common that it has an option to create new pods without deployment. And this is because the kubelet is also managing the pods, that many containers for services and integration, giving it options, privileges to manage pods. But how we can use it without any option to execution, any commands, or open a port or something for the container. So as you can see, first of all, it has also another privileges we can use. It's very common to have privileges to edit config file. And if you have option, as you can see, we did here, we checked if we have those privileges. Config files have configurations for implementing some kind of additional settings for the containers. As you can see here, there's a config file, and we can, by default, you can add execution commands to this config maps, and you can use it by default to get, when you have, with those kind of privileges, to perform code execution by adding here a command on any pod that you want and exist in the config maps. And the second method, that it's to create a vulnerable container. And for this, I don't have access to create some kind of a service. This is why I've used more silent way, and it's for using a tunneling, and without any option to execute some kind of commands. How I did it, first of all, we can create on Docker Hub or in our own local registry container repository, we can create a new, to build a new image. In this image, I've configured automatically OpenSSH, and I set this password and username to something that I know. And I configured tunneling, and on the right you can see that I added the ngrok token to the configuration. And for the execution, I did that in the moment that the container will run up, I will be able to, it will connect to my tunneling service. But I can't get the ngrok address. And this is, but I found that by default, we have access to view the container logs. And this is why I validated that the ngrok will save its outputs on the logs in the arguments. And we'll also need some kind of to-do list techniques for breaking out to the node. This is why I chose privileged container. You can utilize any other techniques that you want. I found it the easiest way. And additionally, you want to break out to the node. So this is why if you don't want the default node, you need to specify here the node that you want to create the pod, and then you will break out to its node. As you can see here, I've created I saw from the logs the ngrok address, and I logged in using the username and password that I've configured. And now I can get into the after I break out from the container, into any configuration that I want on the node that I wanted. And you can deploy this on any node that you want. By this, you can get access to any node. And also using this, the node contains the data of any pod that you want. So you can enter the pod and to search for other service accounts that you can get, and even to get more privileges or more secrets to other integrations or platforms. So this is the demo. First, we check in if we're running in a container. This is one of the methods. Now we can authenticate to get the token and speak with the metadata. There are several ways to do it without, if the metadata is blocked, there are several techniques that can speak with the metadata without being monitored, or if it's even blocked, if it's using IPv6 or any other technique. I've used the regular way. After we got the log, the role, we're configuring it from our local machine. Don't worry, those credentials doesn't work anymore, so you can utilize it. I got all of the tags of cloud. You can see it, even other VMs that I have on my AWS. You can also describe instances by default. Those are the main privileges that exist. see the read-only privileges. We're listing the pods. Then we'll use the secret name from here to get the actual secret. And we can do it for every container inside the environment. We can get its secrets. Need to, as you can see, we cannot list secrets, but we can get its value. And also many times developers are blocking the get secret option, but they don't know that if you have the option to list the secret names, you still can see the value. And this is another way, but it's not by default. But it's also very common. Now we see that we have an option to create new pods. We get our vulnerable container. By default, it's creating the container on the node of the namespace if it's configured. If not, it's creating it on the default with the default policy that exists. We got access to the node file system, to the host. Here is a kubelet config. And this is all the data of all containers. Thank you.